The last section in this particular unit will refer to linear systems, so I would like you to take a moment to copy down this note and then we'll go through it together. So when we're talking about the solution to a linear system, we really are just referring to the point of intersection. And if you recall from before, intersection just means meeting. So we would be looking to graph two lines, and wherever the lines intersect, that would be the solution to our linear system. And keep in mind that when we find the solution to the linear system, we'll get both an x-coordinate and a y-coordinate that represents that point. So that x and y coordinate will make sense or will satisfy one of the lines as well as the other line. So it will be the one point that makes sense in both of our lines. In order to handle this, though, for us this year, all we're going to need to do is just to graph both lines on the same grid and find out the coordinates of the point where they cross. Because we're going to be getting our answer directly from our graph, it's going to be really important to be accurate as you draw your graph. So you're going to need to use your ruler and some grid paper in order to make this happen. Here's an example of a linear system, and I'd like you to take a moment right now to graph each of these two lines on the same Cartesian plane. You have your x and your y axis over there, and then find the point of intersection of those two lines, and that will be the solution to your linear system. It's that simple. Okay, pause the video and take a moment and do that now, please. Let's take a look at the first line, y equals 1/2 x minus 3. I'm hoping that you recognize the form of that line right away and that you see that it is in slope-intercept form of a line. After recognizing that, we should very quickly be able to find out what the slope and the y-intercept of the line is. So the slope is equal to 1/2 and the y-intercept is -3. So recalling what we've done in the past, I'm going to use the y-intercept to plot a point that lies on that line, and then from that y-intercept, let's rise up 1 and run 2 to generate another point on the line. So up 1, run 2, up 1, run 2, up 1, run 2. So we can keep doing this to generate other points, and I am, unfortunately, because I'm doing this on my iPad, I'm not able to use a ruler in order to make my line nice and straight. So yours is probably going to be much nicer than mine. So next thing we're going to need to do is to take our second line, x plus y equals -6, and we're going to rewrite that in a form that will help us to graph it very efficiently. If we wanted to, of course, we could go ahead and just find the x and y intercepts. That would be a possibility. We could also go ahead and change it to slope-intercept form of a line and work it through like that. If we wanted to change it to slope-intercept form of a line, we notice that we have a plus x on the left side of the equation. We need to subtract x from both sides of the equation. We will get y equals -x minus 6. So taking a look at this particular line segment, we could say that m is equal to -1 and our y-intercept is equal to -6. Following the same sort of pattern from before, I'm going to start at the y-intercept at -6, which is down here, and I'm going to go up 1, left 1, up 1, left 1. So once I've extended that line, we can see that the point of intersection is where our two lines cross. So that's actually the solution to this linear system. So I need to read the coordinates of that point off of our grid. So starting at the origin, I notice I'm going 2 units left, so my x value is -2, and 1, 2, 3, 4 units down. So I would say, therefore, -2, -4 is the solution. So kudos to you if you got that right. Now that we have the solution to the linear system, I want to check our answers to make sure that we've done this correctly, especially since we're reading it from the graph. It's really very important that we make sure that this point was the correct point, because lots of times it's hard to have a lot of accuracy when you're graphing. So we're going to use the left side, right side approach in order to check our solutions. So here's equation number 1 that I've written in blue. The left side is y and the right side is 1/2 x minus 3. Since we're trying to check to ensure that our solution is -2, -4, it makes sense, I hope, to actually substitute those values in for x and y. So the left side of our equation, which is y, we'll replace with the -4, and then the right side will replace the x variable with the -2. So working it through, I'd say 1/2 of -2 is -1 minus 3, and then pulling those together, we're getting number 4 equals -4. So notice that the left side equals the right side here. That means that -2, -4 lies on the line y equals 1/2 x minus 3. Take a moment now and work out the check for the second equation as well. Making the substitutions as we did with the first equation, we'll see that in this situation we also show that the left side was equal to the right side. So this ordered pair, -2, -4, satisfied both of the equations that we had, which means that that point lies on both of those two lines that are represented by those equations. The only way that that can be true is if it's a point that they share, or the point of intersection of the two lines, and that's why we've verified that it is indeed the solution. Let's take a moment now to copy down this question. It's a nice application style of question. It's talking about a video rental company that has 2 monthly plans. The first plan charges a flat fee of $30 for unlimited rentals, and the second plan charges $9 plus $3 per video. I want you guys to create a graph and use the graph to figure out under which conditions you would go with the first or the second plan. So there's lots of different ways you can do this. I want you to create a graph, so you're going to have to look and consider what you're going to place on each of the two axes. So consider what your variables are that you're wanting to graph there. I would also like you to create a couple of equations that describe the situations for each of the two rental companies, and then use the equations and the graph that you create to decide when you should use Plan A, under which conditions would you sign up for something like that, and what conditions would you sign up for Plan B, etc. So take a moment and try that now, please. So one of the things that you need to decide is where your variables are going to go. Your vertical axis is going to be cost, because cost depends on the number of videos. So I'm going to use the variable n down here on the horizontal axis to represent the number of videos. You can choose however you would like to establish your axes. I've chosen that each tick on my graph will represent $2, so that every fifth tick is $10. Of course, I'm starting down here, and I think I'm just going to make each tick represent a single video. So I'm just going to mark off where 2, 4, 6, 8, 10, etc. are located, just to make it a little bit easier for me to fit in here. Because I have a stylus that I'm using, it's not as fine as a pencil or a pen would be. So then let's consider what the equations for Plan A and Plan B might be. Let's consider what the equation will be for Plan A. It says that Plan A charges a flat fee of $30 for unlimited rentals. So if we choose to rent one video, it's going to be $30. If we choose to rent 10 videos, it will also be $30. So notice that it's not depending on the number of videos. For that reason, we don't need to have the number of videos in our equation. Cost is just 30 regardless of what we do. If you take a look at that, that's like a y equals 30 graph that we would have graphed using our xy axis, and if you recall, that's a horizontal line. So I'm going to create a horizontal line that represents that plan, and I'm putting an arrow at the end because it applies to however many videos I want to rent. Let's take a look at our second situation for Plan B. It's saying that it charges $9 plus $3 per video. I'm hoping that as you guys saw this, partial variation popped into your head. We've got a fixed cost plus a variable cost. So we've got our 9, which is our initial value, plus $3 per video, or 3N. Lots of times when we go to graph something like this, we want to put the variable term first, so 3N plus 9. We recognize that the 3 over 1 is the rate of change, or the slope, and 9 is the vertical intercept. So I'm going to start at the vertical intercept, and then I'm going to use the slope to generate our line. So I started at 9 and I had a rise of 3 and a run of 1, and I did that all the way along my graph to make it a little bit easier for me to see where our two lines intersect. So if we take a look at this, we could see that the point of intersection of our two functions is 7, 30. So I want you to take a moment to try to think about what this really means. When the number of videos rented is 7 videos, it's costing $30. And that's the point where Plan A and Plan B cost the same. So let's write in which Plan A is. So Plan A was the horizontal line, and Plan B was the one that was the partial variation that had the measure of slope that wasn't 0. So if I don't rent very many movies, which plan would be the best plan for me to sign up for? If I rent a lot of different movies, which plan would be best in that situation? So I want you to take a moment and consider that and to write that down. So pause the video, take a minute to try that. So hopefully what you can see that if you rent more than 7 videos in a month, then Plan A is going to be the best plan for you to use, because you're going to be paying $30 and you're not paying more than that. If I am a person who rents less than 7 videos, then clearly Plan B is going to be the cheaper option for me. I can pretty much guarantee that you're going to get a question like this on your EQAO exam, and it's a nice way to tie together a lot of the different concepts as well as your really good thinking skills to try to solve a problem. Here are some questions from your textbook that I would like you to try to practice now. When we come back to class tomorrow, we will take these up and I will be checking this homework. So make sure that it is finished, please. This is the last section in this unit, which means that tomorrow on Friday, after I check your homework, we will be starting to do our review questions for this unit, which means that our test will be next Tuesday. That will allow you time to ask questions tomorrow on Friday, but also on Monday if the need arises. We will be starting our new unit on Monday, but you will have time to ask questions as well. So good luck today, guys. Enjoy math. See you tomorrow.